We are taking R.D. Sharma Solution Class 12th. Chapter is Probability and exercise is the second exercise. 2 cards are drawn without replacement from a pack of 52 cards. Find the probability that both are kings. Now you need to understand about the cards before solving the cards problems. There are 4 kings, there are 4 queens, 4 jacks and 4 aces. So these are the aces followed by the jack, king and queen. Now this question is valid if both are kings, both are queens, both are aces, like that. So we'll make the events. A is king in first draw. That is, whenever we draw a card, the first card show up to be a king. The another event is a king when you draw the second card. But the important part is we are not replacing the first card. So the probability of A, that is getting a king in the first draw, it is equal to total number of cases in the denominator and total number of favorable cases in the numerator. So what all are the possibilities? 52 cards are there. Any one of the card can be drawn. So 52 possibilities are there. Now we are specific about king. So there are only 4 kings in these 52 cards. So our favorable cases can only come out from these 4 cards. So 1 from 4 can be drawn. So all 4 are the favorable cases. Now coming to the second event, which is B. Now replacement is not being done and we are aware that the first card has come out to be a king. So when A is known, what is the probability of getting a B? And B is again a king in the second draw. So we have taken 1 card out of 52. So 51 are left. Total number of cases are possible, or total number of possibilities are only 51 now. 1 has been drawn. And since we have 4 cards, 1 has been drawn and it is king. So only 3 kings are left. So 1 can be taken out from these 3. So total number of favorable cases are 3. So the probability comes out like this. Probability of A intersection B. First and second card A intersection B. That is, first card should be a king, second card should be a king without replacement. So it will be probability of the first king multiplied by the probability of the second king. 4 by 52 is 1 by 13. Let's write 1 by 13 here. 3 by 51 is 1 by 17. When we multiply this, 1 divided by 17 into 13 is 221. Now calculation is not very important here if you understand the concept, because if you understand the cards, then you will be able to find out the events. Now this is how you are going to write it. This is the full flow or the procedure. English is very important in this. 2 cards are drawn without replacement from a pack of 52 cards. Find the probability that the first is a king and the second is an ace. How many kings are there? We have just seen. There are 4 kings in a deck of 52 cards. And how many aces are there? Again, the aces are also 4. So 4 aces are there. So the first needs to be a king and the second card being drawn needs to be an ace. So we, as I said, English writing is very important here while writing the events here. So the first event is A, that corresponds to the king being drawn as the first card. The second one is an ace is being drawn in the second draw. So ace comes out in the second draw. Now we have not replaced the king, or we have not replaced the first card. So the probability of getting a king in first draw, 52 cards in all, 52 possibilities in the denominator. There are 4 kings, any one can be drawn, so 4 are the favorable cases. Total number of cases in the denominator of favorable cases in the numerator gives you the probability. Now we know that the first card is a king now. What is the probability of getting the second card as an ace? Now don't worry about this. This is just a conditional probability representation. But there are 52 cards, 1 has been drawn. When 1 card has been drawn, 51 cards are left. So 51 cards are the total number of cases. But the card of getting a king doesn't affect the ace because ace are still 4. So total number of favorable cases of ace are 4. And means and represents intersection. So probability of A and B together, that is getting a king and ace thereafter, is probability of getting a king multiplied by probability of getting an ace. Probability of getting a king is 1 by 13, 4 by 52 is 1 by 13, and probability of getting an ace if king is being drawn earlier is 4 by 51. So this will be 4 divided by 13 into 51. When you multiply this, 51 into 13 comes out to be 663. So 4 divided by 663 is the probability of this question. Now how we are going to write this? This is how we are going to write it. Now this question, 2 cards are drawn without replacement from a pack of 52 cards. Find the probability that the first is heart and the second is red. Now heart is a different aspect and a red card is a different aspect. Heart is a sweet. There are 52 cards. In this 26 cards are black and 26 are red. So 26 black and 26 red. Now in this 26 black there are 2 sweets, 13 spades and 13 clubs. In the 26 red cards there are again 2 sweets, 13 will be diamond and 13 will be heart. So this is known to you, but I am just reiterating so that it's a kind of revision. Find the probability that first is a heart. How many hearts are there? I just told you that there are 13 hearts. So hearts, diamond, club or spade, they all are 13, 13, 13, 13. But the red cards are 26. That is, in 52 cards, 26 are red and 26 are black. Now let's make the event. The first event will be the probability of getting, or the event of getting, first card as an heart. So when we draw the first card, it comes out to be a heart. Coming to the second event, the second card comes out to be a red card. So second card is a red card. So probability of A, it's A actually. So these two events are, the first card is always independent, but the second card is dependent because its probability depends on the first card. It changes accordingly. So probability of getting first card, heart are 13. So favorable cases are 13. Total number of cases are 52. Total number of cards are 52. So we have 13 by 52 as our PA. Now coming to the probability of getting the red card. So as we know that the first card has already come out to be a heart, the probability of getting a red is PB by A. Now 52 cards were there, one is already been drawn, there is no replacement, so 51 are the total number of cases for us. But getting a red, and you know heart is also red. So heart is red and red is red. So when you take 1 out of this 26, that is 1 out of this 13 actually, so 12 heart are left. So in total there are red cards, how many? That is, in 26 red card, 1 card has been drawn, which is incidentally heart. So 25 cards are left. 25 cards are the favorable cases. Please remember, heart is a sweet in red only. Now we have a AND, so we need both to be multiplied. Actually we wanted to find the PA intersection B. That is PA multiplied by PB by A, and PA is the probability of getting a heart, and probability of getting red is PB by A. So 13 by 52 is 1 by 4. 25 by 15 remains like this, 25 by 51. And when we multiply this will be 25 divided by 51 into 4, which is 204. This is the probability of this question. Now this is how we are going to write. I explained you the logic. A bag contained 20 tickets, numbered from 1 to 20. 2 tickets are drawn without replacement. What is the probability that the first card has an even number and second an odd number? Now even numbers are those numbers which are divisible by 2, odd are those numbers which aren't, or which are not divisible by 2. So let's diagrammatically understand this question. So there are 20 tickets from 1 to 20. Let me write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Now this writing is very important. You cannot just predict it. The mind is, human mind, maybe if you have a high IQ it's possible, but for normal moderate people, just write it. Now the question is actually giving you the answer. The first card has an even number. So the first event we will write it as first draw. When you draw a ticket from the bag which contains 20 tickets, the first card came out to be an even number. So first ticket, even number. I am writing it in short. You have to write it in full. Remember, B is the second ticket. The number turns out to be an odd number, and means you need to find out the multiplication or intersection of these two events. So first has no problem. Probability of A. First ticket is even number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20 in all, but favorable cases, that is even numbers, are 10. So 10 by 20 is the first ticket comes out to be an even number. We have counted them. Probability of getting a second ticket as odd number. as we are aware that the first card came out to be an even number. So PB by A. Actually, it is just the probability of getting the second ticket as the odd number. So in 20, you have taken one card, so only 19 are remaining. So total number of cases will be 19 only. But we are left with only odd to be found out as a favorable cases. Because first card was even, it has not affected the odd numbers. So 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10. So there are 10 even still left because it was not been taken out. Odd number being left, even was taken out. So 10 odd are left. So 10 by 19. So probability of getting the first ticket as even number and second ticket as odd number, we just multiply them. That is the probability of A multiplied by probability of B. And since we have already taken care of the 19 number, that is 10 by 19 has come only because one was taken out. So half multiplied by 10 by 19 and 2 5s are 10. So 5 by 19 is the probability of this particular question. Now this is how this needs to be written. As I told you, writing a proper English plays a very vital role in this particular kind of solution. An urn contains 3 white. Urn can be understood as a box or a bag or some container. So let me make a container to better understand what we are going to do in this question. An urn contains 3 whites. So this is 3W, that is 3 white balls. Let me write white also. Now the second one is 4 red balls. So I'm writing 4 red balls. There are 4 red balls. Then the 5 black balls. 5 black. 2 balls are drawn one by one without replacement. We are not replacing it. What is the probability that at least one ball is black? What does it mean? So at least one ball is black. That is what we will do here is, we'll not go the right way. We'll go the shorter ways or a smart way of solving this. We will only know or understand the probability of white and red, and we will subtract the total of this with 1. So 1 subtracted, if 1 minus W and R, the probability of getting white and red, if you subtract it, then you will get the probability of at least one block is black. I hope you got the idea. We'll not concentrate on black, rather we'll concentrate on white and red and subtract it from 1. So the events will become like this. First draw, white or a red comes out. We are drawing 2 balls. So the first draw can be white and red or red. The second draw gives you white and red. So white, it can be white, it can be red. Now we will subtract it from 1. Then we will get at least one ball is black probability. What is the probability of getting a white or a red? Now how many whites and how many reds are there? 4 plus 3, 7 are our favorable cases. So 7 divided by what are the total number of cases? 5 plus 4 plus 3, that is 12. Now probability of getting white and red, if it is known that white or red has been drawn in the first place. So this is actually A only in the denominator. So PB by A, probability of getting white or red in the second draw. This is equal to what? Now in all there were 12. But one has been drawn, it can be white, it can be red. So the total number of cases has reduced to 11. White or red were 4 and 3. That is in all 7. But one has been drawn. It can be white, it can be red. But 6 are left. So 6 are our favorable cases. The probability of getting A intersection B, that is probability of getting either red or black in the first and the second draw, is 7 by 12 into 6 by 11. That you already know. This will be 7 by 22. Now this is the probability of getting a red or a white ball in the first and the second draw. First can be red, second can be white. First can be red, second can be red. First can be white, second can be white. And the fourth combination will be first can be white, second can be red. All these possibilities are there, and this has come out to be 7 by 22. But we are interested in at least one is blacks. At least one should come as black. So at least one black will be simply, this will be equal to 1 minus PA intersection B, that is 1 minus 7 by 22. 22 minus 7 is 15. So 15 by 22 is the probability of getting at least one black. Now this is how this needs to be written, and you are aware now what we have done. Now this question is also similar to that one, and a bag contains 5 white, 7 red and 3 black balls. So understand it diagrammatically. We have 5 whites, 7 red and 3 black. So these are the balls. 5 means there are 5 balls. 1, 2, 3, 4, 5, like this. Understand it like this. If 3 balls are drawn one by one without replacement, find the probability that none is red. There is no ball as red. So So if nothing is red, we will ignore red. We'll not talk about red. We will only talk about the white ball and the black ball. White and the black ball. So A is the probability of getting first draw, white or black. I'm writing it in short. I'll show you what exactly you have to write. Now the second draw, again white or black. In the third draw, again white or black. We are not interested in red. We are not talking about red because the question wants us to do that. So the probability of getting white or black. How many white and black are there? If you combine them, 5 plus 3, which is 8. But the total is 5 plus 7 plus 3. You have to compute and collect all of them. So the total number of cases is 15, but the favorable cases is white and black. So white and black, how many whites are there? How many blacks are there? 5 and 3. So white plus black is now 8. So 8 by 15. So 8 by 15. Now probability of getting the second white or a black. If it is known that the first has already come out to be white or black. Now just subtract 1 from numerator, 1 from denominator. That is the logic you can apply. Or that is the trick. So it will be 7 by 14 in here. Why? Because now 14 are left, 1 has been taken. In 8, you have already drawn 1 white or 1 black. So 8 minus 1, 7 by 14, 1 by 2. Now probability of getting in the third white or black, that is PC divided by A intersection B. So in again 14, 1 has been taken, so only 13 are left. In 7, again 1 has been taken because we are just talking about white and black. So 6 by 13. Now what is the probability of getting white or a black, because we don't want any red. So this is equivalent to having no reds. So PA multiplied, that is probability of getting white and black in the first draw multiplied with the same thing in the second draw multiplied by the same thing in the third draw. So I'm multiplying these all three. It will be 8 by 15 multiplied by half multiplied by 6 by 13. You can cancel out these numbers and you'll get 8 by 65. Now how are we going to write about it? You are aware that this is very important. English-like explanation to the examiner that you have understood this question. Now other questions we'll do in the later part. Thank you so much. Have a good one.